Once you've defined your batch or stream feature pipelines using the Tecton framework and registered them with the Tecton apply command, Tecton takes over by orchestrating a process called materialization. Materialization is the process by which Tecton schedules jobs to pre-compute and publish features to the online and offline feature stores, so they're always ready for use when requested. These materialization jobs read from raw batch or stream data sources, apply post-processing and transformations, and publish the processed feature data to the appropriate stores. In this video, we'll dive into how to configure your feature views to materialize data effectively, tailoring the setup to meet your specific use case needs. We'll start by learning how to configure materialization for your batch and stream feature views in Tecton. You can enable materialization for your batch and stream feature views using the online and offline flags. This allows you to control whether features are published to the online store, the offline store, or both. Materializing to the online store is crucial when you need low latency access to the latest features for real-time inference. By enabling online materialization, Tecton ensures that features are pre-computed and instantly accessible, allowing for quick responses in real-time applications. Once data is materialized to the online store, you can retrieve it using Tecton's HTTP API or the Tecton Online Retrieval Client, providing seamless access to the latest feature data whenever needed. For batch and stream feature views that support real-time inference, materializing to the online store is required. However, if your use case is purely batch inference, online materialization may not be necessary. Materializing to the offline store is ideal for optimizing offline retrieval queries, making it faster to build training datasets or perform batch inference. The Tecton SDK provides methods like get features in range and get features for events to retrieve data from the offline store, streamlining your workflow. While materializing to the offline store is optional, it can significantly boost the performance of offline feature retrieval queries and reduce additional computation overhead at query time. If you decide not to enable offline materialization, Tecton will compute feature values from the raw data on demand, as needed. This may be a preferred approach if your features aren't frequently used in a production model. Once materialization is configured, Tecton handles the process of keeping your features up to date through two types of jobs: backfill and steady-state materialization. When you register or update a feature view with the Tecton apply command, Tecton automatically sets up backfill and steady-state materialization jobs for any feature views with materialization enabled. To understand backfill jobs, let's first look at the feature start time parameter. This configuration sets the earliest date from which a user can retrieve feature data from the online and offline stores. Tecton may still run materialization jobs for periods before this date if it's necessary to compute feature values available starting from the feature start time for features such as time window aggregates. Let's assume we set the feature start time of our feature view to day 2. The period between this feature start time and the registration time of the feature view is known as the backfill period. Once a materializable feature view is registered, Tecton schedules backfill jobs to populate the online and offline stores with feature data across this backfill period. By default, to minimize costs and optimize resource usage, Tecton divides the backfill period into roughly 10 equal intervals and schedules a job for each interval. If you need to adjust the number and duration of these jobs, you can use the max backfill interval parameter. This configuration specifies the maximum time interval each backfill job is responsible for. By increasing max backfill interval, you can reduce the number of backfill jobs, with each job covering a larger time interval. Steady-state materialization refers to the continuous jobs that process new data as it arrives in your raw data sources, ensuring that features stay up to date. For batch feature views, steady-state jobs run on a regular cadence set by the batch schedule parameter. This schedule controls how often Tecton launches these jobs, impacting feature freshness in the online store and the unit of partitioning in the offline store. For example, a batch schedule of 1 day triggers a materialization job daily at 12 a.m. UTC. This keeps the feature stores updated with the latest features once per day, ensuring a maximum feature freshness of 1 day. For stream feature views, a single stream materialization job continuously processes and materializes new transform features as events flow into the stream. This setup ensures that features in the online store are always updated as data arrives in the stream in real time. If you're using Tecton's Stream Ingest API, however, there's no need for a separate materialization job. Instead, Feature transformations are handled directly by the Ingest API server, which writes to the feature stores with each ingestion request, enabling real-time updates. In batch feature views, each materialization job runs at the end of its batch schedule period. For example, the job to materialize data from day 8 to day 9 will run at midnight between day 8 and day 9. However, sometimes events for a specific period may arrive late in your data source, missing the scheduled materialization job. To account for this, Tecton offers the data delay configuration on your batch source. When a data delay is configured, Tecton will wait for the additional time specified by data delay before scheduling the next materialization job. This helps ensure that data that arrives late is included in the feature computations, preserving data accuracy. Next, let's look at how a materialization job reads, filters, and writes data from your raw sources for a specific materialization period. Here we have a feature view that reads user transactions from a batch source and writes the transaction amounts for each user daily. By default, Tecton applies a time filter to the raw data, reading only rows with timestamps within the specified materialization period. In this example, each job reads only the raw data for its designated day, ensuring that only the necessary data is processed. This approach optimizes both performance and resource efficiency. For some use cases, like custom aggregations, you may need to read more data than what falls strictly within the materialization interval. Tecton offers the select range method, which allows you to specify a custom data range for each materialization job. Using select range, you can leverage Tecton's time anchor constants, referring to values like the materialization start and end times, or even unbounded past or future times. For example, you might configure each job to read data from the beginning of the data source up to the materialization job's end time. If your use case requires reading the entire data source for each materialization job, you can use the unfiltered method. This approach bypasses time filtering, allowing each job to read all available data. Remember, raw data filtering only applies to the read path. It determines how much data each job reads from the raw source. When the job writes data to the feature store, filtering follows the feature view's timestamp field. Only rows with a feature timestamp within the materialization job boundaries are written to the online and offline stores. Let's now explore how materialization jobs are triggered, whether automatically on a set schedule or manually when needed. By default, feature materialization runs automatically on a schedule set in the feature view definition using the batch schedule parameter. This automated materialization keeps features updated without manual intervention. Batch and stream feature views also support manually triggered materialization, which can be initiated through an API call. You can trigger manual materialization using either the Tecton SDK or the Tecton Airflow provider. When the batch trigger of the feature view is configured to manual, Tecton won't schedule any automatic batch materialization jobs, and they can only be started manually through the Tecton SDK or Airflow provider. The Tecton SDK provides interactive classes with methods to trigger, monitor, and cancel materialization jobs. Using the Trigger Materialization Job method, you can initiate a job for a specified time range, ideal for a one-off backfill from the feature start time to the current time. For regular operations, you'll likely want an automated setup that materializes features for the latest time period as soon as the upstream data for that period becomes available. Maintaining a reliable, consistent state for materialization jobs is crucial to ensure that data pipelines are delivering fresh, accurate data to your models. Monitoring these jobs allows you to catch and address any issues early, helping to keep feature pipelines healthy. Tecton offers several tools to monitor materialization, including dashboards in the web UI, email alerts, and the metrics API. We will first look at the Tecton web UI. To check the status of a materialization job, you can go to the Materialization tab for the specific feature view in the Tecton web UI. This dashboard displays the status of each job that's run for the feature view and provides relevant metadata and logs, which are useful for monitoring and troubleshooting. Tecton also supports automated alerts for materialization health and feature freshness. These alerts can be configured to send notifications to a specified email address, helping you stay informed of any issues. To set up alerts, use the alert email, monitor freshness, and expected feature freshness settings when defining your feature view. Tecton's Feature View Not Fresh alert is triggered when feature data becomes stale. meaning new features aren't being materialized as expected. This can occur due to missing upstream data, job errors, or unavailability of compute resources. The threshold for freshness is set by the expected feature freshness configuration of the feature view. For stream feature views using Spark, Tecton manages Spark structured streaming jobs that continuously update feature values as new data arrives. Stream monitoring is essential to protect against scenarios where models might be using outdated features. By quickly identifying issues such as job failures, lags, or missed updates. Even if a stream job is running, it may not be producing current feature values. For instance, the job may be under-resourced and falling behind new events, or the upstream data source itself might have no new data. In the Tecton Web UI, the Stream Feature View Monitoring tab offers key metrics to assess the progress and health of your stream feature view. These metrics help you monitor for any lags or interruptions in feature updates. Tecton also makes these metrics available through the Metrics API. By integrating them into your application performance monitoring systems, such as Datadog and SignalFX, you can build custom dashboards and set up alerts tailored to your specific monitoring needs. That concludes our deep dive into materialization in Tecton. Today we explored how to configure, schedule, trigger, and monitor materialization jobs to ensure that your features are always up to date and ready for production models. To learn more, check out our documentation and other videos for additional guidance on building robust data pipelines with Tecton. Thanks for watching, and happy building!